Maths 2. In that, we'll be starting with the topic that is trigonometry. Very important topic from your higher studies point of view, and it is one of the important topics in your 10th standard. So, in order to understand it well in our 10th standard and in order to score good marks, it is a compulsion part that we should know its basics properly. So, from that point of view, I have selected this topic to revise this topic. We have already done this topic. So, trigonometry is a topic which is useful in understanding the ratios of a sides of a triangle, angles of a triangle. So, how how it name derived or how it comes at trigonometry. Trigonometry means studying the three sides of a triangle. Means we are studying about the sides of a triangle, its measurement, and when it comes to sides, it angles also plays a very important role. So when it comes to angle, is this concept applicable to all the triangles? No. Further, you can see that the triangles can be converted to right angle, or we can make the triangle to a right angle form by doing some construction. But right now we are going to study about the trigonometry in which the triangle that is being involved, all the triangles will be right angle. So hope all of you know the meaning of right angle triangle. Whenever we are going to have a triangle ABC with one angle 90 degree, this angle, you can see square at one of the vertices. The square indicates a right angle that is 90 degree. If in a triangle any of one angle is 90 degree, then that triangle is said to be a right angle. Now we'll study about a name that is trigonometry. What does this mean? Tri means three. Tri means three. Gono means gona means side. Three side. And actually it is metry means its name is metron, which means measurement. So three side measurements. How it is useful? It is useful in many ways. Actually, we are studying trigonometry. Why? Because if we can see that a tree, if somebody asks what is the measurement of this tree, what is the height of this tree, so how you will measure it? So there, this concept is useful. Also, if you are traveling along a seashore, so if you're standing on the top of the lighthouse and somebody asks you, suppose this is your lighthouse, this perpendicular line, there is AB, suppose this is your lighthouse, you're standing here. You're standing here and this is your seashore. And your ship is somewhere here. somebody asks you how far is the ship from the seashore, then how you will answer this? So in order to answer this, study of trigonometry is important. If you will be understanding this concept properly, then you can easily answer all these answers. Wow, what is the height of the tree? How far is the ship from the lighthouse or from the end of the seashore? So let's study it in detail. These are the applications why we are studying trigonometry. So why study of trigonometry? Uh, a student says, "Sir, this all are we are doing Reto 5. We are not using this trigonometric concept anywhere." No, it's not like that. In 10th standard, you will be doing its application, where you will come to know how important and how how application oriented this topic is. So, and not only 10th standard, in your further studies, if you opt for engineering or medical, before that, you have to go through science stream. So, in that, we are having trigonometry topic, trigonometry 1, trigonometry 2, and all that. So, this topic is to be done very thoroughly. So, when it comes to right angle triangle, we know that one of the angle is 90 degree. So, how actually we can study this trigonometry? Let's first start with terms related to right angle triangle. So this is x, y, and z. Angle y is 90 degree. So therefore, triangle x, y, z is a right angle triangle. Okay. Any one of the angle in a given triangle is 90 degree means that triangle is right angle triangle. We all know this concept. So now, when I will talk about angle Z, what are the specialties of angle Z? First of all, we will see that, and as we have done in our 8th standard triplet form, in which we have seen side opposite to 90 degree is hypotenuse. Okay. Side opposite to 90 degrees hypotenuse. Always remember, hypotenuse will not change. It is fixed. Opposite to 90 degrees hypotenuse. Side opposite to angle Z. This is side opposite to angle Z. At the same time, this is side opposite to Z, but at the same time, it is attached to X. We always be considering only those angles which are other than 90 degree. So we will not be taking this Y anytime, means adjacent to Y or opposite to Y. No, not required. Only we have to deal with, as we are standing here, this is our object. This is fixed. It's not going to change. We cannot move the tree from one place to another place. As I've given you a real life example that measuring height of a tree or how far ship is from a boy standing on the top of lighthouse. So we're going to change this x and z, but this is going to remain fixed. So always we are going to see the terms related to angle x and angle z. XY, side XY is opposite to angle Z. At the same time, side XY is adjacent to angle X. Wait, I will write all this so that you can understand. Otherwise, it will create a confusion. side xy is opposite to angle z. Why we are doing this? These are very important concepts. In order to solve first exercise, we should be very much thorough with this concept. It should not create that confusion of the type it is whether it is adjacent or it is opposite. Once we are very much thorough with the concept, we can easily solve. And trigonometry is not a further a difficult topic. It's one of the simplest topic if you concentrate here. Just try to understand what I mean to say. Side xy is opposite in front of angle z. Side opposite to angle z. Okay. Similarly, we can say side xy is adjacent. Adjacent means attached. Side xy is adjacent to angle x. Yes, it is correct. You will say why hypotenuse is not adjacent. As it is fixed, it is hypotenuse. We can't take it as a side. Always it is going to act as a hypotenuse. Always you'll be getting a side of the type xy or yz. You should keep in your mind. Hypotenuse is fixed. Side xy is opposite to angle z. Side xy is adjacent to angle x. Yeah. Also, what about yz now? I can write here. Side. I'm talking about yz. Side yz. To whom it is opposite? To z or to x? It is opposite to angle x. Side yz is opposite to angle x. Also, side yz is adjacent. We know that this yz is adjacent. It is adjacent to angle y or it is adjacent to angle z. I told you that angle y will not be involved in this as it is fixed. So always there is vary in angle x and angle z. So always when it comes to adjacent side, as it is attached to angle y as well as angle z, you should consider z. So also side yz is adjacent to angle z. Okay. So from here, I hope you all are thorough with the concept. When it comes to side xy, it is opposite to angle z but adjacent to angle x. When it comes to side yz, it is opposite to angle x and adjacent to angle z. Yeah. So by this, we are thorough with the terms related to right angle. So let's do one example which will help you to answer the question after this concept, whatever we have done right now. So on page number 102, they have on page 102, they have given us a triangle in the example that is PQR. Let's take that triangle. Triangle PQR with Q as 90 degree. They are asking us to complete the activity. So let's complete the activity. Side opposite to first. Side opposite to angle P. Yes, now go for angle P and see who is opposite. Which side is opposite to angle P? Angle P is here. Opposite to angle P is, you can see this side. So this side is QR. So you can write here side QR or side RQ. Both means the same. Until and unless it is having a direction. Next, side opposite to angle R. Side opposite to angle R is equal to, you can see angle R here and opposite to angle R, which is that side PQ. Okay. These are the first two answers. Very simple, huh? Side opposite to and adjacent to. This is fixed part. Here side PR is nothing but opposite to 90 degree. So it is termed as hypotenuse. It will not come into the picture because we are going to deal with angle P and angle R. As we have done side opposite to angle P and angle R, now we'll be dealing with at side adjacent to angle P and angle R. Third part, side adjacent to angle P is equal to, who is adjacent? Adjacent means attached to angle P. Which side? There are two sides, PR and PQ. We are going to select PQ. As per my explanation, and this is the actual concept in which PR is your hypotenuse and adjacent to angle P is PQ. So hypotenuse remains fixed, so we have to look for the adjacent side, which is other than hypotenuse. Fourth, side adjacent to angle R is equal to, you give the answer, side adjacent to angle R, adjacent. There are two sides, PR and QR. Which are going to select? QR, correct. Side adjacent to angle R. Why not PR? Because it is a hypotenuse. It is fixed. Okay. So this was the basic concept in which we have studied about angles having opposite side and adjacent side. Once we are very much thorough with the concept, we can easily answer the trigonometric function, that is the sine, cos, tan, which you find difficult, will become very easy for you. Let's take one homework in which I'll be asking you the same, but wordings will be different. If we'll be doing that, it will be helpful for you. X, Y, Z. So I'm asking you, this triangle XYZ is a right angle triangle with Y as 90 degree. So triangle XYZ is a right angle triangle with angle Y is equal to 90 degree. So now some questions based on this triangle. Side opposite to angle X is equal to question mark. Second, side adjacent to angle X question mark. Third, side opposite to angle Z question mark. Fourth, side adjacent to angle Z question mark. So hope you can easily answer this. I will give you hint. Side opposite to X, Y, Z. Side adjacent to X, XY, not XZ. Why? Because it is fixed. This is hypotenuse. Side opposite to angle Z, that is XY. Side adjacent to angle Z, YZ, not XZ, because it is hypotenuse. That we have done terms related to right angle. This is very important. You should be thorough with this. Now we are going to start with trigonometric ratios, in which we'll be dealing with sine, cosine, and tangent. As we have seen trigonometry, and that was a Greek word. Similarly, we are going to have a word for angle, Greek word. Greek word theta. Or you can say theta means like this. Or in like this, make 0 and make chord. Theta. Alpha. You can use this notation for alpha. For beta, this is your beta. So this all are Greek letters. We'll be using as an acute angle for our purpose in order to understand the trigonometric ratios, that is sine theta, cos theta, tan theta. So we'll be using this first Greek letter. It's called as theta, theta. So let's start with the trigonometric ratios, in which first we'll be dealing with sine. Hope you got this Greek letter theta. Now we'll start with triangle, right angle triangle actually. Say the triangle is PQR, PQR, triangle PQR is a right angle triangle with angle Q equal to 90 degree. Okay, so your triangle should be compulsorily what? Right angle. This is your hypotenuse. This is your hypotenuse. This is fixed, huh? It's not going to change. I'll be taking first we should deal with angles, and then let's give it a name as theta, alpha, and beta. First, let me make you comfortable with using letters that we have right now. Formula for sine. This is one of the trigonometric ratios. So what we're going to deal with Trigonometric ratios. Which are they? Sine, second, cosine, third, tangent, fourth, cotangent, fifth, secant, and sixth, cosecant. Now, these are the names actually of the trigonometric ratios, in which we write sine as, or we take it as sin, sine, and cosine as cos, 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 and tangent as tan, tan is capital, but we normally use small t, tangent of, and cotangent as cot, cot, sine, cos, tan, cot. These are the brief that we're going to use. And for secant, we'll be using sec, and for cosecant, we'll be using cosec. So let's study about them stepwise, step by step, so that it becomes easier for us. Only thing you should remember the formula for sine and cosine. All others can be easily derived from them. Let's see how. So first, we'll start with sine. Sine of an angle. We are always going to have sine of an angle, not of a side. Sine of angle. Say let's take sine of angle R. Sine of angle R. So you just normally write sine R is equal to, what is the formula for sine? Is opposite side of what? Opposite side of angle. What we are having? We are taking sine of R. So R upon hypotenuse is fixed. So just write hypotenuse. So as per our understanding and explanation about the earlier concept, we know that opposite side of angle R. Yes, we are having R here. Opposite side to angle R is what? PQ. Very simple for you. We have done 2 to 3 examples. So side opposite to angle R is PQ. Hypotenuse is fixed. I have written hypotenuse, so it is PR. So this is the answer for sine R. So simple. Similarly, if I'm going to ask you, please find sine of angle P. So what will be your answer? Here is P. What is the formula for sine? It is opposite side upon hypotenuse. So opposite of what? Opposite of the angle that you are taking. I'm taking here angle R. So I'm dealing with opposite side of angle R. Here I'm dealing with angle P. So opposite side to angle P is QR. Is visible to us. So sine P is equal to, right, opposite side of angle P upon hypotenuse. Hope so. Things are very clear. Side opposite to angle P. Just have a look. According to diagram, we are having side opposite to angle P is QR. So hope so. Here it is visible. If not visible, I will be writing on top. Sine P, opposite side of angle P is QR upon hypotenuse is fixed, so it is PR. Very simple, very simple. We have done sine of angle R as angle P. We can't take sine of angle Q. Why? It is fixed. It is 90 degree. And further we'll be studying that sine 90 degree is nothing but 1. We will prove it later on, but right now it's not required, as we are doing with basics, which are the important concepts, very useful. Let's start with second part, second trigonometric ratio, that is cosine. Cosine means, I'll write here, cosine means cos of. If I'm asking you cos of angle R, formula is we have done opposite side for sine. So for cos, we are having adjacent side. That's why we have studied the concept of opposite side and adjacent side and hypotenuse. In triangle, which is opposite side to which angle, which side is opposite or adjacent to which angle. According to that, we are dealing with. Why this was important, now you are getting it. Because in sine, we are having a definition of the sine as opposite side to the angle that we are taking divided by hypotenuse. And here we are having a concept of adjacent side of the angle. So we can see adjacent side of which angle we are taking? Angle R. Adjacent side of angle R divided by hypotenuse. So adjacent side of angle R, which is the adjacent side. Two sides are attached to angle R, PR and QR. So as per our explanation, hypotenuse is fixed, so the side which is adjacent to angle R is QR. So QR divided by hypotenuse, which is fixed, that is PR. Okay, and this is clear. So now we'll go for cos of angle P adjacent to or adjacent side of angle P divided by hypotenuse. Adjacent side of angle P. See, PR is fixed, so adjacent to P is PQ. Divided by hypotenuse is PR. Yeah. So even we have completed now cos. Now we'll move to tangent. That is third ratio. Tangent means tan of, you can use a capital letter or even small letter, no problem. I'm writing here tan of. So if they're asking us find tan of R, formula for tangent is opposite side divided by adjacent side. So opposite side of angle R divided by adjacent side of angle R. Opposite side of angle R divided by adjacent side of angle R. Yeah, which is the opposite side of angle R. Opposite is PQ upon adjacent side of angle R is QR. So PQ upon QR. Done. So this is tangent of R. So we have done 3 trigonometric ratios. Right now, in your first exercise, we are having only sine, cos, and tan. As we have done it for R, we can similarly do it for P. Let's complete that part. And after that, we'll be writing formula in terms of theta, as well as in terms of general form, you can write, say, that is sine ratio, cos ratio, and tan ratio. So very useful in order to solve our practice set 8.1. So similarly, tan of P. Tan of P in the sense tangent of P is equal to formula opposite side of angle. Which angle? We are considering angle P, so we'll be writing angle P divided by adjacent side of angle P. Very simple, you can easily answer. Opposite to angle P is QR, adjacent to angle P is PQ, not PR. Why? Because PR is fixed and it is hypotenuse. So opposite to angle P is QR divided by adjacent is PQ. Done. So we have seen even tangent part. So now what we'll be doing? We'll be doing this in terms of theta. Let's do it in terms of theta now. So let's take any of the one angle as theta. What you will like to select? I'm selecting here angle R as theta. Angle R as, you can select any angle in the sense other than Q as theta. Even you can select this P as theta or R as theta, because both are acute angles. As we know that sum of a measure of angle of a triangle is 180 degree. One is 90. So sum of other two angle is 90. So they are always going to be less than 90. So let's start with this. As we have seen earlier, sine of R means now I can write instead of R, because I have given it a name. I have denoted it as theta. Angle R is equal to theta. Angle R is equal to theta. So now sine of theta is equal to this. You can answer accordingly. Sine of theta is equal to, just don't write side opposite and all that. Who is opposite to theta? PQ. Right side PQ. No problem. Who is hypotenuse? Right, PR. Yes, PR. Good. Directly, without formula. Sine theta is side opposite to theta upon hypotenuse. Side opposite to theta is PQ and hypotenuse is PR. Similarly, cos theta, side adjacent to theta is QR divided by hypotenuse. Hypotenuse is PR. Okay, even this is done. You can write small t or capital T, no problem. So tan of theta is equal to opposite upon hypotenuse. So opposite to theta is PQ upon adjacent to theta is QR. So this is the answer for sine theta, cos theta, and tan theta. So let's write this in general form, that is sine ratio, cos ratio, tan ratio. And after that, I'll be writing this general form, that is sine theta, opposite side of angle theta upon hypotenuse and all that. This was the example to make you understand the trigonometric ratios, the terms related, so that things will become very simple for you and easier, so that you can easily deal with the trigonometric ratio, that is sine, tan, and cos. Till date, we are knowing three ratios, that is sine, cos, and tan. As we will proceed, we'll be coming across cot, sec, and cosec. So let's write important formulae. First, there is sine ratio. You can write sine ratio is given by opposite side upon hypotenuse. Second, cos ratio is equal to adjacent side upon hypotenuse. Third, tan ratio opposite side upon adjacent side. Opposite side upon adjacent side. Okay. So this is the important formula for the practice set 8.1, as well as I'll be writing this in terms of theta. So how we can write in terms of theta? Hope you have written this. I'm rubbing. You should copy this sine theta. Sine theta is given by opposite side of angle theta, right, in that manner, so that it will avoid confusion. Opposite side of opposite side of angle theta divided by hypotenuse. Cos theta adjacent side of angle theta divided by hypotenuse. Tan theta is equal to opposite side of angle theta divided by adjacent side of angle theta. Yeah. So this all are the important aspects for practice set 8.1. Still we are having 5 minutes, so we can do one problem of a practice set 8.1. So as we have seen that right angle triangle, its application, how it's going to be useful, how it is useful for your further studies. And after that, we have seen the terms associated to right angle triangle. After that, we have seen trigonometric ratios, in which we have seen sine function, cos function, and tan function. These all are the ratios. Now, we'll see how that Yeah. Practice set. (8.1). In that question number 1, what they have given us, triangle PQR with angle R as a right angle. So diagram is of this type. This is P, this is R, this is Q. And R is 90 degree. Okay. So they are asking us to write the following ratios to find given triangle PRQ is a right angle triangle with angle R as 90 degree. Okay. To find sine P, sine of angle P. This is first. Second, cos Q. Third, tan P. And fourth, tan of Q. Out of third and fourth, I will be solving any one for you. Second one will be homework for you. And first and second, I am solving for you. No problem. First, sine P. Sine P is equal to, what is the formula for sine? As I've written earlier for you, formula that you need to remember, opposite side means opposite to angle theta. Here P is acting as an angle. Opposite to angle P is R cube. So side opposite to or opposite of angle we have written opposite side now, so don't write side opposite. It will create confusion for you. Write opposite side of, no problem. Opposite side of angle P upon hypotenuse. Hypotenuse is fixed. Side opposite to 90 degrees hypotenuse. This is fixed. So opposite side of angle P is RQ or QR, you can say, divided by hypotenuse is fixed, that is PQ. Done. We have completed first. Second is cos of Q. This is Q1. Cos of Q. Cos of Q is adjacent side of angle Q divided by hypotenuse. Adjacent side of angle Q, even QR and QP both are adjacent, but QP is hypotenuse. It is being fixed. So adjacent side to Q is QR. So QR divided by hypotenuse, that is QP. Okay. Now I will be solving 10P. You can do 10Q. 10Q is homework to you. Third, 10 of P is equal to opposite side of angle P divided by adjacent side of angle P. Yes. Who is opposite to angle P? Is QR. Who is adjacent to P? PQ and PR, but PQ is fixed, so we'll be taking PR. Done. This is the answer. And for this, homework for you. Hope you have enjoyed the session. In next session, we'll be completing practice at 8.1 and we'll proceed with the remaining concept. Thank you, everyone.
Thank you, sir.
Thank you, sir.